Okay, so since my phone ran out of space and I realized that I was just talking to myself for about 5 minutes, we're gonna go back and finish this example up and add it to another video. So it says the base of a solid bounded by y is equal to x squared, y equals 0 and x is equal to 2 is the region used for this question. For each cross section, the cross sections are squares. Find the volume of the solid. Now, so the volume when we're doing a square is going to be the integral of the side squared. Now, we're going about the y-axis. So when we go about the y-axis, we have to have y limits. So our y limits are going to be between 0 and 4, okay? Because the intersection point, when I was to plug in a 2 into this graph, you should get a 4. Now, it's important to know that whenever we go about the y-axis, you have to have x equals, okay? So, just like we did in the previous lessons, when it's x equals, or we're going about the y-axis, it's right curve minus left curve. So, to find the volume of the solid, we're going from 0 to 4, and it's right curve minus left curve, and that's pretty much all there is to it. Now, what I'm going to do now is I'm going to go over the worksheet that says volume by cross sections in your packet. And we're just going to do setups. We're not going to worry about the semi-ellipses. We're just going to do the stuff that we've pretty much talked about, okay? Because that's pretty much all that shows up on the AP exam. So number 1, it says that we're doing y is equal to x squared minus 1, which is this parabola right here, and y is equal to x plus 1. Now, for part A, it says we're perpendicular to the x-axis for all of them. Okay, so perpendicular to x-axis. So our ladders would be like this, right? And for part A, it says we're going to find the volume using squares as the cross sections. Now, our intersection points is something we need to do first. So we're going to set x squared minus 1 is equal to x plus 1. X squared minus x minus 2 is equal to 0. And we're going to factor it down. Sorry if y'all couldn't see that. So x minus 2 and x plus 1 is equal to 0. So x is equal to 2 and x is equal to a negative 1. So those are going to be our limits for our integrals. Now for part A, we're doing a square. So for a square, your cross-section area is side squared. So it's just going to be top curve minus bottom curve squared, like that. Ta-da, you're done. If you want to put in the calculator and get an answer, you can put it in the calculator and get an answer. Part B, rectangles with a height of 1. So a rectangle, the area is going to be base times height. Well, your base is going to be your top curve minus bottom curve, just like we did in the previous examples. And your height is going to be 1. Ta-da, you're done. Part C, we're going to skip. Part D, equilateral triangles. Same limits. Area of an equilateral triangle is square root of 3 over 4 sides squared. Your side is going to be top curve minus bottom curve. Ta-da, you're done. Okay. Number 2. Okay, so we have x squared plus y squared is equal to 4. So if you don't know what that graph looks like, that's going to be a circle with a radius of 2. Don't really look too good, but I'll go with it. Now our cross sections are perpendicular to the x-axis. Now, what we did earlier is, in the example problems, is we solve for y is equal to, and we have plus or minus square root of 4 minus x squared. Okay, our limits are going to be between negative 2 and 2. And for part A, it says we're going to do squares for our cross sections. So your limits are going to be -2 and 2, and our side is going to be top curve minus bottom curve. So you can do it like this. Or you can make it to where this turns into a plus plus and combine your like terms. Okay, so that's our integral setup for part A. For part B, equilateral triangles. So the area of equilateral triangle is going to be square root of 3 over 4, side squared, and your side is going to be top curve minus bottom curve, which is going to be the same for all of them. Okay, part C, semicircles. Now I told you to memorize this one. Sorry, this is volume. I don't know why I put area. It's volume. My bad. Okay, so volume of a semicircle is going to be pi over 8 times top curve minus bottom curve. So we're just going to set it up like that. It's easy as that. The hardest part is just memorizing the formulas. On the next one, it's pretty much the same thing. This last one, number 3. Okay, so number 3, y is equal to x cubed. It's going to look like this. Y is equal to 0, and x is equal to 1 is right here. So something like that. So this should be the point 1, 1. Okay, so we're looking at that region right there. Now it says we're going to go perpendicular to the y-axis. So we're going to be going this way. So we're going to have to do right curve minus left curve, and we're going to have to solve for x equals. Okay, just like we did before. So part A, it says we're going to use the volume of the solid is going to be using squares. Okay, so our intersection points or our y limits are going to go from 0 to 1 up in the y direction. And we're going to do right curve minus left curve. Okay, part B. It says we're going to do semicircles. Semicircles pi over 8, integral from 0 to 1 of right curve minus left curve squared. So remember, it's pi over 8 times your top curve minus bottom curve squared. Okay, and then for equilateral triangles, equilateral triangles is going to be square root of 3 over 4 times your side squared. Okay, so they're worked out very similar to the example problems. These will come up in the following worksheets. So we're pretty much done with all the new material. It's just going to be practicing from here on out. The next couple videos, we're going to look at some free response and just keep working on it. So if you have any questions, let me know. Thanks. Bye.